And then we will do the same analysis for the overdispersed gene sets. We will focus on pathways that are overdispersed, meaning that we are going to look at the p-value on the L1 measure this time. So L1 was a measure for the dispersion of the gene set along its first principal component. And the p-value was obtained by comparing the dispersion of that particular gene set to the dispersions of random gene sets. So the threshold on the p-value is again 0.05. So all the gene sets which have a p-value for the L1 measure comparison below 0.05 will be retained. And at the same time, we're also going to look at the p-value on the median expression. That's exactly what we have done previously when we looked for shifted gene sets. So, but this time we're going to make sure that the p-value is higher than 0.05. So it means that we will look for gene sets that are overdispersed and not shifted, because there is a bit of overlap. If a gene set is shifted and spread out over a large range of expression values, then it can be shifted and also display a large dispersion. So a gene set can, in theory, be both shifted and overdispersed. But for interpretation, it's simpler that we make a clear distinction between the shifted gene sets and the overdispersed gene sets. So we are going here to filter on p-value on L1. That needs to be significant. And p-value for median expression, but this has to be not significant. And then we have overdispersed gene sets that are not shifted. We are going to check in which samples these overdispersed gene sets show altered activity, just like we did for the shifted gene sets. I'm going to make a heat map. So, and again, you see a clear distinction between the control samples and the treated samples. So the dispersion that is significant for these gene sets is because there is a clear difference in expression between the control samples and the treated samples. We will check how exceptional the spread of these overdispersed gene sets is by making the box plots. Here again, you see that most of them are quite exceptional. They are far away from the boxes. And we check which genes contribute the most to the overdispersion of the gene sets. So in this case, what the heat map will show, the genes that you see here, these are the genes that contribute the most to the overdispersion. So typically they are the most differentially expressed genes, and they can be up or down regulated. And again, we can ask for a table that shows for each overdispersed gene set the 10% most contributing genes.